Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In today's video, we are focusing on paper 6, which is S1, a question from October-November 2011, variant 33, and the question is about DRV, discrete random variable, also known as probability distribution, the chapter in which you calculate expectation of x and variance of x. Now let's read the question. Question number 3. A factory makes a large number of ropes with lengths either 3 meter or 5 meter. There are 4 times as many ropes of length 3 meter as there are ropes of 5 meter. Stop over here and let's grab something to underline the scenario. First of all, there are 2 kinds of rope. There is either the 3 meter rope or there is the 5 meter rope. And there are 4 times as many, which ones? As many ropes of length 3 meters. So these ones are 4 times. So let me just draw one more line. These are 4 times as compared to ropes of length 5 meter. So now before we move on to anything, in these questions, we need to decide which thing belongs where. So first of all, if I'm talking about 3 meter, and I'm comparing it with 5 meter. So therefore, if 5 meter rope occurs once, the 3 meter is 4 times more. So the ratio of 3 meter to 5 meter is 4:1. So let me just remove the sign over here and it's versus each other. That means probability of 3 meter rope, that is 4 over 4 plus 1. Simple ratio which you have learned in basic math, which is 4 over 5. And therefore, the probability of a 5 meter rope is 1 over 4 plus 1, which is 1 over 5. Let me also color label it. So this is the 5 meter one and this is the 3 meter one. So you now have 2 probabilities to work with. Now, every other part, whether it's part 1 or whether it's part 2, or whether it's part 3, they are all related with these probabilities. Now let's focus on part 1. It says one rope is chosen at random. Find the expectation and variance of its length. Now the first part, it's about the basic idea. Let me draw a table over here. It's about the basic idea of a probability distribution. So over here, the length is L, or let me denote it with the symbol X. The length could be 3 meter, the length could be 5 meter. And the corresponding probabilities, this is 4/5 and this is 1/5. What I need to calculate is expectation and variance. So first of all, the formula for expectation is sigma px. Remember, when I use the symbol p, this is actually for this thing, probability x is equals to x. If x assumes the value 3, this is the corresponding probability. If x assumes the value 5, this is the corresponding probability. So in short, we can just write a p over here. So therefore, this is 3 into 4/5 and this is 5 into 1/5, which is 12 plus 5 over 5, and this comes out to be 17 over 5. Leave the answer as it is. That is expectation of x. What is expectation of x square? That is sigma px square. That means these values of x will be squared. So therefore, let me write over here. This is like 3 square. This is like 5 square. The probabilities are the same as before, which is 4/5 and which is 1/5. So therefore, this is 9 into 4, that is 36 over 5. And this is 25 over 5, and 36 plus 25 is 61 over 5. That is expectation of x square. Why do we need expectation of x square? Because we need to calculate variance of x. So variance of x is dependent upon expectation of x square. That is expectation of x square, and definitely it's also dependent on expectation, and this is the formula that we use, which is given in the formula booklet MF19. So therefore, expectation of x square is 61 over 5. Expectation of x is 17 over 5 square. So this is 61 over 5. And this is 17 square is 289. 289 over 25. Now, let me take LCM, or let me work in this way so that I make the denominators the same. So this is 61 over 5. That's a small mistake. And now this becomes 305 over 25 minus 289 over 25. And this simplifies to 16 over 25. That is variance of x. So hence we found out two things. Let me highlight them. The first one is, let me grab a bigger one. So this is variance of x, that is 16 over 25. And this is expectation of x, that is 17 over 5. Now, whenever you find something, it's a good idea that you double underline it so that it becomes prominent to the examiner. Now, let me add a page because I'll be needing more space. And let me grab this thing from here and let me paste it over here. And now I am on second part. So remember, the probabilities were what? The probability, that is not E, it's P. That's probability of 3, that's 4 over 5. And probability of 5 is 1 over 5. Now I'm focusing on the second part. That is, 2 ropes are chosen at random. Find the probability they have different lengths. What does it mean? So which colors have I used? That is the purple and the green. Okay. So now that is purple, and then there is green, and then there is green, and then there is purple. That means a full purple. That means I can choose a rope of length 3 meter and then a rope of length 5 meter, or I can choose a rope of length 5 meter and then a rope of length 3 meter. So this one over here, that is the 3 one, and this one over here is the 5 one. So basically what we do is that we write the corresponding probabilities 4/5 into 1/5, or means add 5 as 1/5. This is 4/5. So this is 4 over 25. This is 4 over 25. Add it up, that comes out to be 8 over 25. Now people usually ask this question, can we write it once and multiply by 2? Definitely the answer is absolutely yes, you can do it. But the question is, in order to make you understand everything in clarity, that is the process that I apply to make it easier for the audience, for the viewers, for you students, so that it's easier to understand. And that is why I use colors a lot. So that's how the second part actually is solved. Now let me move to the third one. 3 ropes are chosen at random. Find the probability the total length is 11 meters. Now, how can I have a total length of 11 meters? So basically 11 can be written as many things, but what about writing this thing as 3 plus 3 plus 5? I think that is the only option. So there are no 2 choices. It's just one choice. There are 2 ropes of length 3 meters and 1 rope of length 5 meter. Again, the color coding. So let me write green over here. Let me write green over here. Let me write green over here. That means, what's the other color? That's purple. So purple, 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 green, purple, green, purple, purple. These are the 3 possibilities that you can have. This is 3, this is 3, this is 5, this is 3, 5, 3, this is 5, 3, 3. This is the idea of permutation. That's where it seeps in. When you have 3 alphabets of which 2 are the same, in how many ways can you arrange it? AAB, ABA, BAA. Calculation wise, this is 3 factorial divided by 2 factorial for the identical A's. Whatever is true for digits, that is also true for letters. So letters and digits, they are identical. So that's how they have to be treated. So probability of 3 is 4 over 5, and probability of 3 is 4 over 5, and probability of 5 is 1 over 5. And there are 3 options. So when there are 3 options, we multiply by 3 for all these 3 options. Option 1, option 2, option 3. So now multiply out 4 into 4 is 16. 16 into 3 is 48. 5 cube is 125. 48 over 125. That is the answer. So let me double check all the answers and let me just highlight them. So this is the answer. This is 8 over 25. Second part, 48 over 25. That's the third part. Expectation and variance is right over here. Let's double check. So now this used to be the time when I used to write down the answers instead of the mark scheme. 17 over 5, 16 over 25, 8 over 25, 48 over 25, and that is the paper. So that was a question from this particular paper, which is October-November 2011, variant 63. I hope you have enjoyed this particular video and understood the concept of DRV in totality. I would like to hear from you in the comments. Stay tuned for more content.